So we're going to do another problem with two objects moving. And this time, let's imagine we got two knights that are jousting. Okay, so we got two knights sitting here on their horses. Okay, and so we got a knight there and a knight over here. Okay, excuse the fact that I can't draw. Okay, so we get a knight here and we get a knight over here, and they're about to joust. Okay, so they are 20 meters away from her. So we'll call this one Sir A, and this one will be Sir B. Okay, so two knights, Middle Ages, they're about to joust, they're 20 meters apart. And so when they start, Sir A starts this way with an acceleration of 1.61 meter per second squared. Sir B starts this way with a different acceleration, so A sub B is going to be 2.05 meter per second squared. So this knight, I guess, on a heavier horse, Sir A is on a heavier horse and moving slower. So they meet somewhere here. So I want to know where they meet. So how far until they meet? And so you look at the problem, and this could be kind of complicated, but you look at it and say, well, it's not that bad, because this one goes some distance x sub A, and this one goes some distance x sub B. Okay, so they both start from rest, so we know that x equals x naught plus v naught t plus 1/2 a t squared. They both start from rest, so here. So for Sir A, x naught is 0, so the distance xa is going to be just 1/2 a acceleration times time squared. Well, what about B? Well, Sir B's motion is completely independent of Sir A. So if we completely imagine that Sir A was not even there, and I asked you for how far did B go, you probably would put an origin there and say that way is positive. If you did that, you would say the distance xb is going to be 1/2 a sub b t squared. Now the problem is we have two equations with three unknowns. We have xa, that's unknown. We have xb, that's unknown. We have t, that's unknown. We know what 1/2 is. We better know what 1/2 is, otherwise this is the wrong class for us. Okay, we know what xa is, that's given. We know what xb is, so xa is given and xb is given. So what do? Think about it, two equations, three unknowns. We need one more equation. And we say, oh wait, we got one more equation. We know that xa plus xb equals the distance d. If we call the distance between the two the initial distance d, that's a third equation. And so now we can solve. So how do we do that? What I would do is I would take xa, substitute in here, and xb, substitute in there. So xa plus xb equals d. So 1/2 aa t squared plus 1/2 ab t squared equals d. So the only unknown left in here is t, so we can solve for t. So algebra tells us that t is going to be the square root of 2d over aa plus ab. So t is going to be the square root of 2 times 20 meters divided by 1.61 meter per second squared plus 2.05 meter per second squared. And so t comes out to be 3.31 seconds. And so now I want to know, well, how far, where is that? That what I found was when they run into each other, but I asked for where. Well, we know that the two knights here start here 20 meters apart, and we know that xa is 1/2 a sub a t squared. So I can find out how far xa went. So xa is 1/2 of A sub A 1.61 meter per second squared times 3.31 second squared. So XA is going to be equal to 8.80 meters. Okay, so what I asked in the problem was, where do they run into each other? So you have several ways of saying. You can say they run into each other 8.8 meters from Sir A's starting point. Or you could go another step and you could say that they end up 11.2 meters from Sir B's starting point. Or you could say they run into each other 1.2 meters towards Sir A from the midpoint. Okay, because they're originally 20 meters apart, so the midpoint's right here, and they run into each other right there, closer to Sir A starting point than Sir B starting point. So there's 3 possible answers here. And so the question is, which one of those 3 answers is correct? And the answer is all 3 of them are correct. You could say this, and I would count that correct on a test. You could say that, and I would count that correct on a test. You could say this, and I would count that correct on a test. But if you just give the number, you got to tell me where you're measuring from in order for me to know if you measured it correctly or not. So you're always better off giving more information instead of less information. And so I'd take any of those 3.